Okay, now we will understand the same thing, that means free RTOS and task with the STM32. Last time we have done this thing through the ESP32, but now we are going to start the same thing, task, through the STM32. So here first of all we have to set up this thing through the QMax. These are the basic step, right? And I will introduce one new thing, like to see the output, right? But let me find, is there any definition for the, okay, these are the warning, but before that let's understand the task a little bit. Before that, like we have done this thing like previously also. So normal in this is right now for the especially for STM32, that we have done few program for the LED blinking and for the reading the input, digital input, right? So how we have done that, we have everything we have put into the while loop, right? And we have used as a delay, right, halt text delay, or as a timer, right? So this work for 3 simple checks, but now add a sensor read the task. That means the same thing, how we will manage the different kinds of multiple tasks at the same time, right? So for that we are going to use the FreeRTOS. Okay, so FreeRTOS solution is job get its own task. Each task use task delay, not halt delay, right? Task delay release the CPU to other tasks during the wait. All 3 tasks appear to run simultaneously. Time is accurate. That means we will not going to use now halt delay. We have used halt delay for the normal programming, but for a FreeRTOS we will use task delay, right? Why? Because whenever the task get the free time, then the CPU allow other tasks to run at the same time, right? It looks like that everything is running at the same time, but CPU managing it through in microsecond or millisecond, right? So this is the concept, like task stack. FreeRTOS task stack, we use this command, we use this instruction to create the task, right? Then we'll it applies a few parameters like the priority and the delay, right? Everything. And then the task is running here, right? After that we have created the task. That means our task is started, right? The task could be on the basis of the mutex, or for the queue management, or for the semaphore, right? Whenever the task is running, we can also suspend this running task through the task delay, right? Or maybe it could be something like it's a timer or delay get expired, then also the task get blocked, or either it will be suspended. And after that we can also resume that same task through the different kinds of command. The task could be again into the resume condition. Okay, and we can use different kinds of command like running, ready, blocks. So these are the status of the task, right? Schedule timeline, half CPU it's shared between the tasks. This is some kind of visualization, right? Let's say our timer is working 0, right? This is the timer, millisecond, right? Here our one task is running, right? Then other task can maybe get blocked for 50 millisecond, right? So this is the basic overview, that what this overall things trying to make us understand, that every task is running not running exactly simultaneously. It can run simultaneously, but over the different core, right? But on the same core, whenever it is getting the time, right, that means it get freed for the other things, then we can run the other task, like counter task is running, uptime task is running, LED task is running, but everything is running on the basis of the free time that every task is getting. Okay, here task delay versus halt delay. This is the difference between that halt delay, burning cycle, doing nothing, right? But task released to other task, right? Whenever we have run this command halt delay, that means our CPU get stuck for the this much of value, that means 500 millisecond. In this 500 millisecond, none of other tasks can work, right? But in this case, when we have the 5 millisecond delay, then other tasks can be run, and it stay running. Waste CPU, it get blocked, right? If it does not have anything to done, then it get blocked, right? Then use FreeRTOS, right? We should skip this part. In FreeRTOS we should mostly, as a good practice, we should use always FreeRTOS, right? This is one example. I think let's say our CPU is as a tea seller, tea owner. Okay, then there is a customer in a line. Then hard delay, that means one customer one customer placed one order, and that customer is waiting to get his order till the 5 minutes, right? No one can place another order till now until that one customer get his order, right? But in case of the V task delay, whenever order is completed in the kitchen, then maybe another person can give his order and wait for the same time. Okay, so that means so that they can serve the different customer at the same time. Yeah, now it's time to implementation. So whenever, first of all, everyone download one thing called putty. I think if you are already, you should have, if you are already working as a developer. Otherwise you can download here from website putty.org. Download putty. Okay, it's very simple and very light application. Just download it and run it. Whenever you have cat downloaded, right, just search in your window, you should get putty environment like this. Yeah, whenever you will get this kind of option. In this we will use the serial, right? It's kind of our terminal in which we can use we can see our normal logs. So in which we will just define our COM port, that means the COM port for our device, and the speed for the communication baud rate. Download it and let me know. Bit on download. Until then, let's see. So first of all, we will do the everything through the QMX setup, right? And before that, we have to enable few things like FreeRTOS from the QMX, right? This is the instruction or steps through our for the QMX. Okay, it's very simple. Let me tell you directly from the VS Code. Sorry, not MX Cube. So here, first of all, we'll create a new project. Okay, procedure was the same. Select your board, Nucleo dash F103. Okay, click new project. Yes, and then load it. Yeah, after that okay, click on project manager, give it a name like LED task, right? Other important thing that I can tell you before that, because I already have, I think, a similar project, then I will use that. So but everyone, please give your attention here, right? It's very important. Whenever we are using FreeRTOS, first of all, go to the middleware. Here you will see that one option, FreeRTOS. Okay, enable it. What we will choose here, CMSys v1, that means version 1 of the FreeRTOS. Okay, done. Other things we can do, but it's not a needed compulsory, but as optional, that whenever you click here task and queue, you can also create task from here, right? Add different kinds of task, name, priority, but you can also create the task, same task, through the coding. Okay, so we'll prefer that we will create the task through the coding, but you can create it from also here. That is not a much big deal here. Okay, so important thing was like enabling the timer, right? Sorry, not timer, it's FreeRTOS. Okay, you can see the same instruction here, right? What are the other things we will enable? System core, from system core we will enable the timing, time based source. That means this timer 1, we will enable the timer 1 from system clock, sorry, system core. Here SYS, right? Here you will see timer 1. Done. The peripheral has no parameter to configure. Okay, for now leave it as it is. Next is FreeRTOS task, yeah, these are the things that that's not use much important. Okay, just important was enabling the FreeRTOS and enabling the timer. Okay, so why change the time base? Time one FreeRTOS uses system ticks for its own 1 millisecond scheduler. All library also need tick source for hall delay. If both use system ticks count, right? Because already the internal architecture of STM32 or internal peripheral that we'll use as a other things. So that's why we will use a separate timer for our FreeRTOS. Okay, and the FreeRTOS has different FreeRTOS APIs layers. So this gives us on 3 different definition create delays. Version 1 is simpler and work perfectly for this workshop. Internally still use real FreeRTOS. Okay, so that's why we are using version 1. Another things you can use, download the putty. I hope everyone has done that. Open that, select the COM port. We will mostly use that baud rate 115200. Right, to find our COM port you can use a device manager. Yeah, next thing is okay, let's directly jump into the code side. यहाँ तक हो गया सब लोगों का? मतलब एक प्रोजेक्ट क्रिएट कर लीजिए क्यूबमैक्स के थ्रू, ठीक है. ये जो सेटिंग्स हैं सिस्टम के अंदर टाइमर वन इनेबल कर लीजिए. अगर आप टाइम वन यहाँ पे कर लोगे ना, देखो एक डिफरेंस बताता हूँ. यहाँ पे आप इनेबल नहीं कर सकते बिकॉज FreeRTOS इज यूजिंग द सेम थिंग. ओके, डन. और सिस्टम को हो गया, FreeRTOS हमने इनेबल कर लिया, ये भी हो गया, ठीक है. अब यहाँ पे प्रोजेक्ट का नाम दे दीजिए, ये सिलेक्ट कर लीजिए और जनरेट कर दीजिए, ठीक है. मोस्ट प्रोबेबली आई शुड हैव अनदर प्रोजेक्ट फॉर द सेम थिंग. लेट मी ओपन दैट. Okay, so I think everyone should have this project. Open it in IDE. From now we will deal with the two files. First one is our main.c, second one would be our FreeRTOS. Before that I want to make you familiar with these things. You can see these comments, right? Right, user one begin code. This is the following architecture also. It will give us a good practice first of all, right? You can also see that now private type def, right? That means variable, right? Kind of type def, like making initializing that what we call that structure or enums, right? Here we can add our private variables, right? Here we can define private functions, public functions, right? So whatever we will add here, if we want to add a private variable, then we will write here, so that our the synchronization between the IDE and CubeMX would be the same. Because if we want to generate a new code after having completed our existing project, then we have to take care of that. Our existing project should not be replaced, right? So our CubeMX will consider the same thing through this comments. Okay, so now follow these notes. And here first of all we'll do task one by one. What is saying that we have to paste these things into our main.c. So basically right now we have to include stdio.h, right, for 20%. Where we want to add, where we have to add it into the user begin, okay? Here where it is user begin, it should be on the top of that user begin. Okay, यहाँ पे हमने इसको पेस्ट कर दिया. Next thing is what we have to add. We have to initialize this task, right? We have to define this definition of this task here. But where the user code begin private functions, right? User code begin. Can you see that? Right, either type def fpf function prototype or I think यही होना चाहिए private function. yes, fp. ठीक है, ये हमने कर दिया. नेक्स्ट इज द कोड. ये हमको ऐड करना है यूजर बिगिन 0 के अंदर. व्हाट इज द कोड? टू प्रिंट द लॉग्स इन द पुट्टी साइड. So let's find the begin one. mm, oh, sorry, my bad. I have to recall it. Okay, no, actually I was in the FreeRTOS. We have to do the everything in the main.c. Sorry, my mistake. So here, first of all, in the code begin, user begin include, we have to include stdio.h, and for ftp, yeah, fpfp, here we have to initialize this function, sorry, definition of the function. And then in the begin user code begin when, we have to put, oh shit man, what is going on, comment. Okay, I think I forgot to add a star here. Okay, yeah, keep remember that, do not miss any. If you have, okay, if you have copy this code from here, then yeah, I think there is one mistake in the notes. You have to star one, you have to add one star here before the forward slash to make it both line as a comment. Okay, keep it remember. And then next thing should be, yeah, phase 4 user code begin 2 के अंदर हम क्या ऐड करना है, we have to add our start of logs where we are going to add into the begin 2, right? Go to IDE, find that user code begin 2, right? You can see that 8 code here. Done. Next thing that we are going to paste here is between the हमको जहाँ पे जो है user code begin RTOS thread, that means STM32 architecture is already defined that place that where we have to add everything, right? RTOS thread already decided that where we have to place, find it. You can see this is the queue here. Okay, user code begin of RTOS thread, ठीक है, add thread here. Done. We have added 3 threads मतलब task, right? What are the tasks we are going to edit here? One LED task, second was a counter, second and next one is startup uptime task. Okay, next I think we have done with the main file. Now we have to add FreeRTOS.c, right? There should be a pre-built file, it's called FreeRTOS.c, just about the main.c, FreeRTOS.c. Okay, so instead of adding manually everything, we will just copy this code, right, and control A, paste. Okay, again I think I have missed something. There is a
Star.
message.
Yes, yes.
Star. Okay. I think there is also one more mistake in the notes. Got it. Third mistake in the notes. Okay, yeah, done with mistakes. Don't forget to press Control S every time whenever you have changes. Okay, now okay, let's first of all get overview about this code here. We have done with the embedded C in a FreeRTOS. We have just added the definition for each task, right? And then these are the by default you have to keep that we application get ideal task memory, right? It is compulsory and we have to add, right? Which is most of time we do not add to add here. It should automatically generate through the QMX. What we have added here, task, right? You have just developed the different kinds of task in VS code for the ESP32, right? In a similar manner, we have added one task here, right? And then task is not much critical. We have initialized one variable toggle LED and the initial value was the 0. Then added printf for. I hope everyone know about it. Is similar like while loop, right? It is like that. For semicolon, that means it is equals to while 1. Okay. Then after that we have toggled the GPIO pin, incremented the counter, and we are checking that counter value if it is print every 10 toggle, right? Whenever they when divided by the 10 and it get remainder by equals to 0, then it will print that toggle value here. Okay, this is the task for the LED. This is the counter in which we are just increment the counter and printing those value, and this is the third task, right? We are printing logs and getting the ticks, get stack high watermark. Maybe we'll get one error here because I think we have to enable.
I'm getting that error.
Sorry.
I'm getting that error when I
Yes,
build
yes,
a project. It's showing
yes.
that error.
Most probably the error should be because of this instruction. Okay.
Okay. So what we need to do to remove that?
So what we can do right now, I think we do not go into the deep, and the task is not relevant for us. So for now, skip this task. Okay. But if we have deleted this task, from where we have to delete also? We have to delete it from here also, right? We can't leave empty definition, and the main.c, we will check main.c. We have to delete also, save time from here, right? Start counter, and the last time we have to decide on delete from here also. From three place we have to delete the same, the task definition. Okay. Now click on the task, build into project. Warning not used function. Okay, build completed. Let me flash it. Let me check if it is working or not. Debug STM32 application. Configure. ST-Link. Scan. Enable. Apply. Okay. No link detector. Why? Eleven 500. Open. Why it is not giving us output? Because what do we print reset here? Definition comport device manager. What is it? Okay. We have not used which function was. It should paste on the user code begin 0 here. That means okay. Let me rebuild it. My mistake. Okay. So you should see this kind of output on putty. Now from we will use putty as a serial terminal. Okay, and also along with it your onboard LED. That means that we are using here in the FreeRTOS. When I will check that the LED task, right? We are using LED port 2. That means in our we are using inbuilt LED. Okay, the LED should blink in every second. In the same time, your log should be print along with the blink of LED. Okay.